All of this out here is your white matter. Everything in here is your gray matter. This would be your dorsal horn. This is your ventral horn. The dorsal horn is where your sensory neurons terminate on interneurons. And remember, an interneuron is completely contained in the central nervous system. The cell bodies are in that dorsal gray horn. And we have sensory information coming from your back, so you feel things on your back. You can detect temperature on your back. You can feel pain on your skin in your back. We also have sensory information coming from the anterior part of your body. And again, all of those sensory neurons begin on receptors. In your homework packet, I try and show you a receptor. It's basically drawn like this. Have you seen this picture in your homework packet and you've wondered, what the heck is that? It's a receptor. So this one would also begin at a receptor. Now true, your spinal cord is in your dorsal cavity. The ramus means branch. The branch coming from your back is small. There's not a lot back here that's more posterior than your spinal cord. The branch that is coming or serving the anterior part of your body is much bigger because there's more stuff ahead of your spinal cord. These are the first two branches, so they're called primary rami. Ramus means branch. So this is a posterior primary ramus and an anterior primary ramus. From them, you can have even more branches. You can have a cutaneous branch. You can have a musculoskeletal branch. And if you go back and look at the CNS chapter and you look at the spinal cord sections, you will see that labeled. We're not doing anything in the hood, so when I'm done lecturing, I will report it. So again, posterior primary ramus and anterior primary ramus. Neurons that are found with their cell bodies in the ventral horn exit, and they are now either going to enter a posterior primary ramus to muscles in your back, just kicked back on, didn't it? Or they will enter the anterior primary ramus and again terminate on skeletal muscle. And in your homework packet, that's how I made the picture for skeletal muscle. Okay, I think the airflow is disconnected. When I talk about spinal nerve plexi, these plexi are out the anterior primary rami only. The green is just another sensory neuron. They're coming off the ventral horn, so they're somatic motor. So the anterior primary rami can start to braid together from many different levels. It's a lot like creating a French braid, for those of you who don't know how to French braid. Let me quickly demonstrate. And when you make a French braid, it stabilizes the hair involved in that braid. And if you keep doing this, and you have enough hairspray, which I could always borrow, let's say you forgot your little twist tie in the bathroom. I know it's not pretty. I don't have a mirror. but can you start to see the work of the braid?
Mm-hmm.
Natasha, don't judge me. This is sort of what a plexi looks like. I'm taking hair from different levels. I'm integrating it into this braid, and it gives redundancy, stability. Versus if I, see it's still there, it's staying, isn't it? Versus if I just take the hair and don't create this lattice work from different layers of hair from different parts of my head, if I just do a simple braid, we know you've learned how to do hair. Which one's still keeping together, right? So when the anterior primary rami start to lace together, it gives redundancy. We don't find this all along the spinal cord. We only find it in certain layers or levels of the spinal cord. There are 4 different plexi. There's a cervical, there's a brachial, there's a lumbar, and a sacral. The redundancy is important. If you think cervical and brachial, they're ultimately going to serve the upper member. Think about how much you do with your arms and your hands. If one of those anterior primary rami was severed at one level, you would not want to lose sensation to your entire arm or lose mobility to your entire arm. The lace work creates redundancy. So if one becomes damaged, you don't lose everything in your upper member. For the lumbar and sacral plexi, they're giving redundancy to your lower member, your legs. If one of those becomes damaged, you don't lose everything. You can still feel something on your leg. You can still move muscles of your leg. In your homework packet, I ask you to give me an example of a nerve from each of the plexi. For the cervical plexus, I want you to associate the phrenic nerve. Phrenic nerve is C3, C4, C5. C5 is technically not part of the cervical plexus, but that nerve is a good representation of it. So I want you to count it in that plexus. Then for the brachial plexus, well, I'm going to go over a few nerves from that. In your lab, we do not ask you to identify the different branches and rami, etc., from the brachial plexus. But you should see that on your cat. Have you found all the nerves up here in the shoulder region from the cat? They kind of get in the way of you trying to find all those blood vessels. The brachial plexus is quite large, and it's a whole bunch of cream-colored nerves. Ask Professor Innes to show it to you today if you haven't already seen it. The brachial plexus will lead to nerves called the axillary nerve, the radial nerve, the ulnar nerve, the median nerve, and I'm going to go over in the next slide, if you damage those nerves, what you can expect to have happen in your arm. For the lumbar plexus, the one nerve I want you to know as an example is the femoral nerve. In the video, I tell you, if you find the femoral artery and vein, wrapped up in the connective tissue is a cream-colored nerve, the femoral nerve. So if you found that artery and vein, you can find the nerve. For your sacral plexus, the one that I want you to know is the sciatic nerve. And if you flip your cat over and find the hamstring muscles and separate the semitendinosus and membranosus from the biceps femoris, right in the middle, about the size of half your pinky, will be a large cream-colored set of axons. That's the sciatic nerve. Have any of you ever had a vertebral disc bulging onto your sciatic nerve? It is so painful, isn't it? Your leg, usually the sensations, because when nerves are impinged upon, they can send action potentials up to the brain, and the brain interprets it as pain, even though nothing is technically touching you. And usually when someone has sciatica, they describe that it feels like their leg is on fire, or that someone took sandpaper and just rubbed their skin off their leg. What was your experience?
It's like numb, dull, right down your backside.
Numb, dull, aching pain, tingling sensation maybe. You got off somewhat easy. Some people feel like their leg is on fire.
Every time I drove, I had to drive, like the crossball.
To alleviate the pressure point, yeah, because those ischial tuberosities can impinge on it. So you were trying to like shoving a bun this way. Painful. Did you have to do physical therapy?
I've been in and out of PT for a minute.
Yeah. And it resolves. You got lucky again if you didn't need any corticosteroid shots. Did you? No shots to the back? Then good. You got off pretty lucky. Yeah. So those are the examples that I want you to know. And again, it gives redundancy. So you don't lose everything if there is a damage to the spinal nerve at that level. To quickly go over this, the axillary nerve serves your teres minor and deltoid. If you have crutch paralysis from using crutches that aren't fitted well, it will impinge upon your axillary nerve, and then you will have weakness in those muscles. Most notably, you won't be able to abduct your arms. Radial nerve serves all of the posterior arm and forearm. Those are all, remember lab 2, your extensors. So if you have damage to your radial nerve, you won't be able to extend anything. Musculocutaneous nerve is going to serve the anterior arm. So these are all your flexors at the elbow. Ulnar nerve is going to get the anterior forearm, and in your hand, digits 5, 4, a little bit of 3. Median nerve is going to get the other part of the anterior forearm. So if people have damage to these nerves, like I said, with the axillary nerve, you get the crutch paralysis. Wrist drop. If you have radial nerve damage, you have wrist drop because you can't extend. This is also called the waiter's hand because they're like this, looking for the tip. That's why they call it waiter's hand. Claw hand reminds me of the movie Liar, Liar with Jim Carrey. Claw. Did you see that movie? That's homework. You can't extend the interphalangeal joints. That would be these joints. So you can't do this. So you have the claw hand. Ape hand is usually a result from damage to the median nerve when someone tries to commit suicide by slitting their wrists. They usually get ligaments, and the nerves, you have to actually cut pretty deep to get to the arteries. So usually it's a failed attempt. Well, we don't need to say that on the video. We're getting clues on how to do it properly. That's okay. It's what I need right now in my life. Kara taught us. But when we damage the median nerve, you then get apan, which means you lose the ability for opposition. So the thumb just kind of hangs out in the breeze. Hand of benediction. They lose the ability to flex digits 1, 2, and 3, but the ulnar nerve is still intact, so they can those. So it looks like the hand, bless you children, the hand of benediction. I have a matching section on your exam with these nerve injuries and their presentation. Dermatomes are regions on your body that are innervated by cutaneous branches from the spinal nerve. They are very helpful to us in a clinical setting because if we suspect that someone has had spinal cord damage, it's an easy tactile touching assessment. It's basically, can you feel me now? Can you feel me now? Can you feel me now? And if I move my hands again and the person says no, then probably the spinal cord break was at that level, and that means everything below, even though I'm touching them, the sensory information is trying to get up to the brain, but the spinal cord is severed, so the signal's lost. So that's why they have the loss of sensation and movement as well. So these dermatomes are very important for us. I do not ask you to label the dermatomes on a picture. I simply want you to know that they are regions of the body that are served by a spinal nerve at an appropriate level. By that I mean, does it make sense for a cervical spinal nerve to relay information about the bottom of your foot? But is it appropriate to relay information about touch or temperature on your neck and maybe even a part of your upper member like the shoulder? Of course. So it's a map. Somatotropy. We map these. Another way that dermatomes are clinically important, how many of you have ever had chickenpox? Yeah. You actually had the disease, not the vaccine. Horrible. Well, you now have a life sentence. It's like having a sexually transmitted disease. By that I mean it's the gift that keeps on giving. That chickenpox virus is still living in you. Your immune system has made it go dormant, but it is still living in you. And as you get older, if you get stressed, immunocompromised, that virus is dormant in the nerve endings, and it will erupt, and you will get the blisters all over again along that dermatome, and that's what we call shingles. And it's really, really painful. So around age 60, that's when, for those of us who have had chickenpox, they're gonna recommend that you get a shot. And you might say, well, I've already had chickenpox, what's the point of getting the shot? The shot is to tell your immune system, hey, you need to still be vigilant. If this virus tries to bubble out of the nerve ending, you got to knock it down. And if you have an outbreak, maybe it won't be as severe. We are getting into the time of year where those types of viruses like to come out. It's in the springtime. We're not really sure why. It's the change in the temperature and the weather, more exposure to the sun. But this is the time of year where the chickenpox virus tends to run amok, and also other types of viruses that stay dormant in nerve endings like herpes. So if you have cold sores, you might see that you get more of an outbreak this time of year in the summer months. We know that sunlight has something to do with it, and stress and being immunocompromised, but we're still not sure exactly what provokes it to come out. Caitlin.
At our office, we had 2 cases of chickenpox, and they're both 18-year-old, and they were both fully vaccinated.
It can happen if they were vaccinated too early, and if they didn't finish the sequence. That can happen, and a lot of parents say, oh no, it wasn't done too early, or we finished the sequence. But many times the doctors give the vaccination before what's recommended, and the reason why they do that sometimes is because some doctors are so afraid that the parents won't bring the kid back. So to at least start them being vaccinated is better than nothing at all. So for example, Honey and I we took turns taking them to doctor's visits. And sometimes the line of communication was not kept clear, and we've changed doctors. So vaccination records dropped and that sort of thing. And when one of my sons tried to start kindergarten, it was the school nurse that said, according to these records, Mac had these 2 vaccines too early, they need to be repeated. And they would not let him start school until he had them again. My honey had an issue with that. Oh, no, we're overly, shut up, Jenny McCarthy. I will take him to the doctor then. It's better to get the vaccine than to have the disease. So I'd rather have him get another one to be safe. I don't know if that's what happened, but the older you are, when you do get chickenpox, the worse it is. Like, you will get it in your eyes. Those of you who had chickenpox, did you get them in your eye? Not that you remember. You would remember if you had it in your eye, in your ears, that itch you just could not reach. Nether regions. Yeah, look at them, they're like, really? Yeah, imagine that itch and the judgment people have when you're like, it's not what you think, it's not a yeast infection, it's chickenpox. It's horrible. And like I said, then it can come back. So if you've had chickenpox vaccines or chickenpox, you need to be mindful of current CDC recommendations, medical recommendations of when you should be vaccinated for a booster. Right now it's around age 60, but for some populations, they might recommend that earlier. You need to listen to what your doctor tells you. Otherwise, those dermatomes are going to flare up. Any questions about dermatomes? Okay. Now we're getting to our reflex arcs. Let me take what I drew on the board and bring it over here to perspective. Here's the spinal nerve. We have action potentials coming in. Can you see the arrow? And we also have action potentials that can go out. Here's my analogy for spinal nerves, this part right here. When we have a spinal nerve, I want you to think of that as a restaurant. Where out in the restaurant we have tables, we have booths, and we have wait staff. And if you watch in a restaurant, we have some wait staff approaching a table saying, are you ready to order? And they take your order and they bring it to the kitchen. And if you've ever sat next to the door leading to the kitchen, especially in cafes, you might notice that the doors are double hinged. They swing both directions. And if you watch long enough, you might see that the wait staff, when they're bringing an order into the kitchen, they enter the kitchen through one of the sets of doors, through one set of the doors, the left side, let's say. And when the wait staff leaves with the order from the kitchen, carrying it on a tray, they exit through the other door. Agreed? So there's an in and then there's an out. Why do you think the wait staff need to use a certain door to go in versus out of the kitchen? So they don't crash into each other and make a mess. Your spinal cord is set up the same way. Think of the spinal cord as the kitchen. I need incoming sensory to come in one way. That's the dorsal root. That's the in door. I need outgoing orders, outgoing wait staff to go through the ventral door. Once they're through the door and they're in the main area of the restaurant, then we can have them mixed. We see wait staff taking orders and wait staff saying, here is your cheeseburger. Does that make sense? Okay, but again, any sensory information will eventually have to enter the spinal cord through the dorsal root, the in door. Part of the dorsal root is the dorsal root ganglion, where sensory cell bodies are found for spinal nerves. From the ventral great horn, we find the soma for somatic motor neurons. They're going to exit through the ventral root, the outgoing door. And once we get to a spinal nerve, we're in the restaurant. And from the spinal nerve, we can have a branch lead back to serve everything on your back, not just sensory, but also musculature and sweat glands. And we have an anterior branch that serves everything ahead before the spinal cord. And the anterior branch is always bigger, as I drew over here, than the posterior. Always bigger. Why? Because you're serving more structures ahead of your spinal cord. So if I have sensory information coming in, it's going to terminate on an interneuron. And that information should go up to your brain for higher processing. Don't get me wrong, the spinal cord can make an executive decision on its own. And I'm going to give you an example of that. If sensory information comes in, this interneuron can actually tell a motor neuron, we got to do something now. But while you're handling that, I'm also going to tell the brain about what's happening here, in case the brain wants to get its 2 cents in this matter. Here's what happened to me. I used to babysit for this family of 4. And the children, we had 4 children, so it was a family of 6, but I didn't babysit the parents, obviously. And the children could eat enormous quantities of food, and it used to gross me out. And I hated when I would get tricked into babysitting for them. They would say, oh, we're just going to a movie, a matinee. And I'd be like, okay, I can handle that. And then they did this to me every time. They'd call, well, now we decided to go to dinner. Shit. Now I gotta feed these parasites. And it would gross me out because the two-year-old could eat 2 packages of Kraft macaroni and cheese on his own. And the way he would eat it, he would take the mac and cheese and he'd masticate it. And then he'd get it all goopy and soupy and then just suck it like he was drinking his bottle. It was really nasty. So this particular night, they did the same thing, so I thought, I'm gonna make them a casserole, so I'm not making 10 boxes of mac and cheese. So I made this chicken casserole, and it's done, and I was browning the breadcrumbs. So I had the broiler on. The broiler is usually that hot coil at the top of an oven. I pull down the oven door, I reach in to get the casserole using not oven mitts, but just, what do you call them? Pot holders, pan holders, whatever, those things. And I'm reaching in and I'm pulling the casserole out, and behind me I can hear the baby coming in. I have the hot oven door open. So as I'm trying to pull this casserole out, I'm like this with the kid like, don't come over here, because I didn't want him to come to the oven and like blah, blah, blah. So I'm, and I pull out the casserole, but I'm not looking, and my motor memory, my cerebellum failed me. So I started to pull up before I was completely out, and my thumb hit the hot broiler coil, and I was still so preoccupied with his safety that at first I felt the sting. But then the burning continued and it burned the nerve. So then after a while, I didn't feel anything. And you have 2 different kinds of pain pathways, which we will not get into. If you want to learn about them, you have to take pathophys. There are 2 different pain pathways. There's the quick one, and then there's one, the throbbing, that comes after. So I felt the quick for just a second, and then Corey was okay, and I turned back, and my thumb is still touching it. And so here's the weird science person geek in me. I'm going, that is so cool. And I'm watching my skin melt like Indiana Jones in the Temple of Doom style, when they open the ark and the face melts. So I'm watching my skin just melt, and I'm having these thoughts. That should hurt, but it's not. That is so cool. I should probably pull my hand away. All of that time for me to think about that. And as I pulled my hands out, the skin was on the broiler flapping in the convection current. And then the throbbing pain set in. But that was a moment where my spinal cord reflex arc failed me. It should have been, you need to get that out now, but because of the nerve damage, it didn't get that signal relayed, and it took a while for my brain to go, maybe you should pull your hand out now. So it was a delayed response. I definitely should have had a better withdrawal response, a withdrawal reflex. If your upper member or lower member ever have pain, what's the first thing you do? Say you're walking barefoot on the beach, there's a shard of glass. You step on it. Is your reaction going, oh, yes, yes, let me just grind into that even more? That's inappropriate. What you should do is a withdrawal. You pull your foot away from that. And also inappropriate, you should not pull back both feet, right? It's called the crossed extensor. So you pull away the one that's hurt, but the other one is extended to keep your balance. Now that also happens in your upper member. You have this, what's called the crossed extensor. So if I were to sneak attack on you all out in the hallway and jump out and grab your arm, your reflex, without you thinking, the arm I grab, you would pull away, and with the other arm, boom, you'd extend. And people who actually try and prey upon other people to do bad things to them anticipate that response. They anticipate you trying to pull this way. And so what they'll do is they'll go with you and knock you over, and then they have you. And if you take any sort of self-defense class, which I did, our instructor had to train us not to do this, but to fall into them and catch them off guard, because they're anticipating this reaction from you. Now, reflexes can be innate, they can be learned, they can be based on fear and past experiences. And if you have a certain reflex that you've learned, like this cross extender, like, whoa, I don't know what's happening, it's hard to unlearn that. It's really hard. For example, Mac, my youngest, has been stung too many times, and he's had adverse reactions. He's had to get some nasty corticosterone shots. Those are painful. So he will not go near a nursery. He will not go anywhere out in the garden where there are flowers, because there are bees. And if he hears a bee, he's like, ah! He just can't help himself. It is a learned reaction that he has. So if you act that way because you hear a bee, ah! You've probably had a bad experience with a bee before. Innate reflexes are reflexes that we're born with, like suckling. Babies are born with a suckling reflex. If they can't do that, we start to wonder about brain damage, or are they born prematurely? Another innate reflex that they have is grasping. Grasping. And you can go back in evolution, you can go back to our ancestors, just look at primates in general, and even their babies have this grasping. When the mama monkey has to jump from tree to tree, that baby better learn how to hold on. My brother taught me about that innate experience by demonstrating this on my oldest son, Hayden, when he was just a few weeks old. I went home to my mom's house, brought Hayden home from Texas to show everyone. And my brother says, give me Hayden, you go have dinner with mom, go relax, I've got him. I was like, okay. So I go in the dining room, and next thing I know, my brother comes out from the kitchen, and he starts talking about how he watched on, I don't know, some, not History Channel, but Discovery Channel. He watched some show on reflexes, and he comes in and he starts talking about, do you know that babies have an innate reflex for grasping? And he starts saying how many pounds per square inch that babies have, white knuckling things. And I said, well, that's interesting. Why are you telling me about this? And he says, come see what Hayden's doing. So I'm like, what is my 3-week-old child doing? That is so amazing. And I turn the corner, and my mom's microwave is up high. It has a handle. And from across the kitchen, my infant son is white-knuckling the microwave handle, hanging in air, he can't even hold his head, so his head's like. And I have to now calmly cross the entire kitchen without spooking, because if you go, ah! They're like, oh! That's the startle reflex that they have. Have you ever watched sleeping babies have a startle reflex? It's hilarious. But I don't want that to happen. So I'm calmly going over to my child, unfurl his hands, he's just white knuckling it, walk by my brother. So we're going to do a couple of reflex arcs, but I first want you to go have a break, and then we'll go through the components of 2 reflex arcs. Go have a break. 10-minute break. Go pee. Look, I know Professor Innens tells you to go have a break. She's like, no, get up, walk around. So go, get up, walk around. Okay, components of a reflex arc, there are 5 of them. Reflex arcs, like I said, some reflexes are innate, some are learned. We also can characterize them as being monosynaptic or polysynaptic, and I'll explain what that means on the next couple of slides. Monosynaptic means one synapse. Poly means more than one. But that is very misleading when you look at the pictures I'm about to show you. So I'm going to clarify those terms on the next couple of slides. We also know that some of your reflex arcs can be ipsilateral, which means whatever sensory was detected on that side, the outgoing command also goes to that same side. That's what we mean by ipsilateral, same side. And some are contralateral, where you get the reflex arc crossing over to the other side of the brain for higher processing and then output, so crossing over to the other side. An example would be the withdrawal, the crossed extensor reflex arc. 5 components of the reflex are numbered on this slide, but I'm going to go over them. It all will begin with a sensory component, and that means we have to have a receptor, some sort of receptor to detect a change in your environment, whether it be temperature or pain. Something has to detect some sort of stimulus from your environment. Then we need an afferent fiber. That means we need an axon carrying the action potential towards the brain and spinal cord. Number 3, we need integration. We need somehow for the spinal cord and the brain, or just the spinal cord in some cases, to make some sort of decision. That's what we mean by integration. Then item number 4 is we need to have an efferent or motor outgoing command. And then lastly, that motor command, that neuron has to terminate on an effector. So something that will do a response to the stimulus. If you feel pain, you should withdraw your hand if you touch something sharp. If you step on something sharp, you should withdraw that leg. That would be an example of voluntary effectors that are causing contraction, and you withdraw your hand or your foot from the painful stimulus. Does that make sense? 5 parts. In physiology, we have you really pick apart the 5 components of the reflex arc. So it is good for you to start hearing about this before you're heavily tested on it in physiology. There are some pictures that you're seeing in your PowerPoint. There are also some test pictures that I start to tell you, these are pictures I'm going to use. This is a picture of a spinal cord that you can expect to see on a test where I ask you to draw one of or both of these following reflexes. It depends on which test version you get. You need to know the anatomy of the spinal cord in this picture. For example, here is the dorsal root, the incoming door. There's the dorsal root ganglion. Here is the ventral root, the outgoing door. Here is the large anterior primary ramus, and here is the posterior primary ramus. The other structures that you see here, I'll tell you what they are, but it won't be until Thursday and next week where I start to lecture on them and let you know what they do. So this structure right here is my drawing to represent something called a pelvic splanchnic nerve. Again, none of that means anything to you right now. This structure is trying to show you a ganglion that is part of the sympathetic trunk. Have you seen the sympathetic trunk on your cat? It's not in your hit list, but if I were teaching lab, I would definitely say you all need to see your sympathetic trunk. So probably today, when you start lab and you get out, are you getting out all your cats today? I'll come in and I will quickly show you the sympathetic trunk. I think that will be very helpful for you to see it before Thursday's lecture, because when I start lecturing on the autonomic nervous system, most students think that all of this is microscopic. Most of it is macroscopic. You can hold it in your tweezers. And I think it would help you to see some of these things before I lecture on them on Thursday and next week. So this is a sympathetic ganglion, part of your fight or flight response. This is a communicating ramus. It's a fancy way of saying it's a branch coming off of a spinal nerve communicating to the ganglion. There is a white and a gray communicating ramus, and starting on Thursday, we'll start to, I'll explain what those things do. So again, pelvic splanchnic nerve, communicating rami, there's white and gray. Why do you think one is called white? What's white matter? Myelinated. What's gray? Non-myelinated. What's usually not myelinated? Cell bodies. But in this case, the gray ramus is going to be a collection of axons that aren't myelinated. So again, more on these structures on Thursday. Additionally, on your test, I will ask you, depending on which test version you get, I will put you at a certain level of the spinal cord. And I will say to you, at this level of the spinal cord, some of these structures on this picture would not exist. So in the next week and a half, I need to teach you which of those structures would be present at certain levels of the spinal cord and which wouldn't. And you get like a point for crossing off whatever structure shouldn't be there at whatever level I put you at. And then if you cross something off in your picture, then you should probably not use it. Meaning you shouldn't draw a reflex arc through that structure if it doesn't exist. How do you use something that doesn't exist? So if you cross something out, then don't use it. For example, if you cross out the pelvic splanchnic nerve, where do you think we're going to find pelvic splanchnic nerves? Down here. So if I put you at the level of T1, do you think you have a pelvic splanchnic nerve? No. So you would cross that out. Then if I ask you to draw a reflex arc for a crossed extensor of your upper member, then you shouldn't be drawing part of the reflex arc through that structure you crossed off. You just told me it doesn't exist. So again, 5 components. We have to have sensory receptors. We have to have an afferent fiber relaying information to the spinal cord or brain. We have to have integration where a decision is made. Then there has to be an outgoing command to an effector. Reflex arcs can target voluntary effectors, which is skeletal muscle, or they can target involuntary effectors. And we will tackle reflex arcs that target involuntary effectors Thursday and next week. Again, bring your homework packet so we can work on these things. So monosynaptic reflex arcs, that is your knee-jerk response. Your patellar reflex arc. Have you ever gone to the doctor and you're sitting on the table and the doctor takes that funny looking hammer and hits your patellar ligament? What do? You kick. That's your knee-jerk reflex arc. It is called monosynaptic. I'll explain what that means in just a moment. The crossed extensor, also known as the withdrawal reflex, is polysynaptic. Those are two reflex arcs that I definitely want you to start with and study over the weekend. This picture is somewhat misleading. If you just look at it at first glance, you might be thinking, oh, there's something happening on the right leg and something happening on the left leg. No, this picture is showing you the same leg. It's a before and it's an after, okay? Before and after. So we're still talking about the same leg. In your quadriceps muscle group, you have special fibers that detect stretch. If muscle is overly stretched, guess what you instinctively want to do? Contract. You do. Have you ever been to a yoga class? Or when I was growing up, my parents put me in gymnastics. And it was all about trying to get the splits. And so the Chinese splits, as they used to call it. And the instructor would come by and push on us, trying to get us closer to the ground. And the more they pushed, the more we fought against them. And they would say, stop doing that. And now I wish I could go back in time and say, I can't. It's a reflex arc. I could have all of you lay on your back, put your feet up, open your legs, and if I came by and stretched them down, you would fight me. You would start to contract them together. I would say, relax, stop fighting me. It's a reflex arc. So the more muscle is stretched, the appropriate response is to contract. Why do you think that's so? Because you can pull muscle off the bone. Literally pull it off the bone. So when your doctor does the patellar reflex arc and they hit on your patellar ligament, when they hit that with a little rubber hammer, what it does is causes your quadricep muscles to stretch because they're pushing in on the ligament. So there's a very quick stretch of the quadriceps, and the resulting output to the quadriceps would be to have them contract. And if the quadriceps contract, what do you do with your lower leg? You extend. So if they contract, the lower leg extends. And the doctor is seeing if your spinal reflex arc is reacting appropriately. Now, some of you are just little jerks, and you see the doctor saying, okay, I'm going to test your reflexes. And some of you are like, I'm not going to do it. I'm going to make sure that my leg doesn't twitch. That's a bad thing. You're now showing the doctor that you have spinal issues. Don't do that. So the doctor, in an effort to distract you, if the doctor thinks you're doing that, they might say, can you please cup your hands together like this and pull as hard as you can. And when you do that and you're distracted, the doctor will go, bam, and you'll get your little knee-jerk reaction. And not only that, when you do this up here in the spinal cord, it helps activate lower levels of the spinal cord, making them more sensitive. So it's a little trick that the doctor has. So that's a stretch. Now this one's called monosynaptic. Okay, let's follow this sensory neuron back. And again, I'm going to ask you to draw this. So it's just recreating this picture on your test. So here is your sensory neuron with the cell body in the dorsal root ganglion. And here are two terminal endings. Monosynaptic. Are you seeing only one synapse here? Aren't you seeing more than one? So why do they call it monosynaptic? And here's why. This sensory neuron synapses directly on this somatic motor neuron. Follow the neuron out to which effector? The quadriceps. So because the sensory information came from the quadriceps, synapsed on the motor neuron that stimulates the quadriceps in a one-to-one fashion. That is the reason why they call it monosynaptic. Now, the other part of this, you're seeing it connect to an interneuron, aren't you? And the interneuron is now synapsing on a different somatic motor neuron, which innervates the hamstring muscle group. If your quadriceps contract, should your hamstrings contract at the same time? No. When you had to learn muscle contraction, what neurotransmitter did you write down in your essay that is released onto skeletal muscle? Acetylcholine. And I begged you to know how we get contraction to stop. Do you remember? What did you tell me? The acetylcholine has to be degraded. Calcium has to be resequestered. ATP needs to be used to disconnect the myosin head from actin. And the action potential needs to stop from the motor neuron. Never did I tell you that the somatic motor neuron should release a different neurotransmitter to inhibit the skeletal muscle. Never did I tell you that, because it doesn't exist. So if I don't want the hamstrings to contract while the quads are, then I need this somatic motor neuron. I'm going to go back to my example, back in time. Remember our membrane potentials, the number line? And I said, if the cell becomes more negative, move me, which way should I go? More negative. More negative. Thank you. This was our number. Remember, positive integers, negative. Then we call that, if it gets more negative, what H word? Hyperpolarized. So I want this hamstring neuron to become hyperpolarized so that there's no chance it fires, so that there's no chance that I get both muscle groups trying to contract at the same time. That would not be productive. So again, monosynaptic. The sensory neuron stimulates and activates the motor neuron to get the muscle that needs to contract, reach threshold, so that we get an action potential. I'm going to think about that a little bit. So this interneuron right here, you're seeing a negative influence on that purple somatic motor neuron. There are neurotransmitters that we say are inhibitory. And that means that the downstream cell becomes hyperpolarized, further away from threshold, less likely to fire an action potential. We certainly don't want the hamstrings to contract at this time. As a side note, just kind of fun, there's another kind of danger where muscle can be ripped off the bone. Not from stretching too much, but from contracting too much. And a different reflex arc is at play. When muscle contracts too hard, it can pull off the bone, just like we can pull it off the bone from stretching too much. Did I tell you about my postgraduate friend, Grace? Did I tell you that story? This is when I was working at UCI as a postdoc. And Grace was another researcher in the same lab I was in. She played softball. And I went to this game, and she was playing catcher. And she was in the traditional catcher's stance, right? Up on the balls with their feet, ready to spring into action. So she's in the traditional position. Beer is on the line. Losers have to pay for beer for the winners. So we take this very seriously. And I'm sitting next to her husband. Batter swings, pop fly. It's going to be the third out. We're getting closer to victory. Grace springs into action. Now, what muscle do you use for plantar flexion? Gastrocnemius. That's the main muscle for plantar flexion. So here she is in the heat of the moment. She leaps up, overly contracts her gastrocnemius, rips, and what's the muscle deep to it? The soleus, also involved in plantar flexion. In her enthusiasm, she overrides this reflex arc that is meant to protect her from overly contracting. What do you think a muscle that's overly contracting should do as an appropriate response? Relax. So in her enthusiasm, she's like severe Barbie, right? She's plantar flexing. She leaps up. Next thing we know, she crumples into this ball. She gets up and she's walking like this, and she starts wailing on the batter, just wailing. And both her husband Manny and I are like, and it took me a while, and Manny's an emergency room doctor. So we're both trying to process this. And I finally look at, because Grace is doing this, and I see that she has ripped off her calcaneal tendon, free and clear off the calcaneus. And that muscle, both muscles, are balled up at the back of her knee at the origin. Funniest damn thing I've ever seen. Sorry, it still makes me laugh. And the reason why she's wailing, so I'm like, Manny, look at her leg. And so he goes running over to Grace, tackles her, gets her to the ground, and Grace is like, lay down! She thought the batter swung and hit her in the leg so that she couldn't catch the pop fly. So the pain she felt, she thought was caused by the batter. So she's wailing. And he's tackling her. And he's like, Grace. He's like grabbing her. Grace, look! Oh, it tickles me to this day. I was back before cell phones had cameras. That definitely would have been like on social media and nothing flat. Look at this. That's a different reflex arc, but I thought you would enjoy that story. I think it's hilarious. Here is a crossed extensor using the arms as an example. Now this picture is showing you two different arms, a right side and a left side. And in this one, here's where we begin. Someone grabs your arm. That shock of someone grabbing you The sensory information goes through the indoor annual synapse on an interneuron, not directly on the somatic motor neuron, which is why this one is called polysynaptic. It will synapse first on an interneuron, not ever communicating directly to a motor. Some of these interneurons will trigger a somatic motor neuron to activate, innervating your biceps brachii of the arm that's being pulled. If your biceps brachii contracts, you withdraw. But we also have some interneurons sending negative influence to the somatic motor neuron feeding into your triceps brachii. If you are contracting the biceps, you should not at the same time contract the triceps. Also, interneuron crosses over and communicates to other interneurons on the other side. So this is contralateral part now. And now we're going to get the other arm defending you. That's the extensor, crossed extensor. And if you extend your arm, which muscle group should be activated? Triceps. So notice that neuron is now getting closer to threshold. And the biceps brachii neuron should be hyperpolarized because when you're trying to push away, you don't want your biceps brachii contracting. That's not what you want to do. Withdraw the arm that's being hurt, push away the offender with the other arm. Crossed extensor. The same thing happens in your legs. If you step on something painful, you withdraw the leg that stepped on the sharp stimulus, but the other one extends. So now let's do the leg. The leg that's hurt, what muscles should be activated to withdraw? Hamstrings. Which ones should be inactivated? Good, but on the other leg, it's reverse, isn't it? You want extension, so that's your quads that are activated, and the hamstrings would be inactivated. Okay. The innervation of skeletal muscle, these skeletal muscle cells can have special receptors in them. So a muscle can alert the spinal cord and brain if it's being overly stretched or overly contracted. I want you to know the overly stretched example that I gave you, the patellar knee-jerk reaction. And then I also want you to know the crossed extensor. There will be a few more reflex arcs that I will ask you to know and teach you, but they are going to be visceral reflex arcs. And we will focus on the heart, something called the baroreceptor reflex arc. It is part of anatomy, but we use this reflex arc all the time in a clinical setting. So next week, and starting Thursday, I'll start to teach you about that. Very quickly, I want to go through the cranial nerves with you. You have 12 cranial nerves. Because they have the word nerve in it, that means they are part of the peripheral nervous system. There are a couple of acronyms you can use to memorize